All right. Yes, as mentioned, my name is Christoffer. I'm a PhD student in Andreas Larsen Group in Denmark at the Technical University of Denmark. And today I'll be talking about the discovery of myotoxin 2 neutralizing human IgG antibodies. And first, I'll be showing what has been discovered. And then in the end, we have run into some problems. So I would like to take use of all this genius in this room and hopefully get a small brainstorming session going in the end. But for that, I need to be a bit quick. So let's get started. First, I think we can all agree that snakebite is a problem and it should be solved or at least improved. So I won't go into that. Yesterday, you saw two of my colleagues, Anne and Esperanza, talk about this figure. I'll just give a small recap. Right now, the traditional antivenom production is life-saving, but there's a lot of groups in the world that feel like there could be some improvement in this area. And our approach to this is the recombinant antivenom production. For this, you need to discover antibodies, and we do this through also presented technology yesterday from Esperanza and Anne, phage display technology, where we discover an antibody and then the gene corresponding to that antibody. If we have any questions about this, we'll take them in the end because I feel like it was explained quite vividly yesterday. To the actual problem in this talk, we are trying to discover, I've been trying to discover an antibody that can neutralize myotoxin 2 from Bottle asper. And Bottle asper is a snake that lives in Central America down to northern parts of South America. It's been reported to in some of the areas it's living to be responsible for up to 80% of the snake bites and 90% of the snake bite related deaths. Its venom composition varies a lot between ages and between where you pick it up. But in general, it consists of two main groups of toxins, metalloproteinases and phospholipases. Myotoxin 2 is a phospholipase-like molecule without any lipase activity, but still very myotoxic. And myotoxic effects from a Bottle asper bite can be seen over here on the right-hand side. So what's going on when we're discovering these molecules is first, we do phage display as mentioned, where we select between 40 billion different human antibody fragments. From this, we narrow it down to 300 monoclonal cultures. And here, we'll be going into what I'll be showing some data on, where we're going into the actual neutralization testing to see which one of these seemingly high affinity binders actually neutralize. So first, we've done some in vitro neutralization where we've been using human fibroblasts. And this is a pre-incubation assay where we have purified myotoxin 2 combined with each of 6 different IgGs. And we've done this in a 1 to 0.5 toxin to IgG ratio. These have been pre-incubated for 30 minutes and then added to the cells. 24 hours later, we've measured what was the cell viability. And as we can see, does this thing work? Yeah. As we can see, we have a negative control. This is what we want to be at when we have a neutralizing antivenom. Positive control, we would like to get away from this. When we add a non-specific a non-myotoxin antibody, we don't get any neutralization. But if we add one of the 6 that is our prime candidates, we get close to full neutralization at this very low ratio. So with this, we thought it was good enough to continue to in vivo, which is work carried out by Bruno and Julian from ICP. I love working with these guys, and I think they're both watching right now, and just wanted to give a shout out to them. But next up, we have the in vitro neutralization. And this is, again, a pre-incubation assay. So we have same setup, myotoxin 2, together with the IgG at a slightly higher molar ratio of 1 to 1. These are incubated for 30 minutes, added to an animal for 3 hours. And then after that, we have measured the CK levels as a measure of muscle damage. Again, we have the negative control. We want to be low in muscle damage. We don't want to be high. And as we can see, when we add myotoxin 2 and our molecules, we see a great, almost full neutralization of this myotoxicity. One of the molecules we discarded because that doesn't seem like a good antivenom. Next, one quick mention. We also tested one of the current antivenoms against Bottle asper, and we could see that it did not neutralize fully the CK levels, the increased CK levels. Therefore, we thought it would be interesting to continue with our most promising antibody, We call it the blue antibody in this talk. And we would use this to spike one of the current antivenoms with this to hopefully get a full neutralization. So here we've been carrying out a pre-incubation assay again, but this time with whole venom, not only mytoxin 2. Pre-incubated 30 minutes, added to an animal, 3 hours later, measure CK levels. And again, we want to be low, we don't want to be high. And we can see if we add our own antibody at an guesstimated 1-to-1 molar ratio. This is whole venom, so we can't really know how much mytoxin 2 is in there. We see a 75% reduction in toxicity, myotoxicity. If we add the current antivenom, one of the current antivenoms, we also see the same reduction. But if we combine them, we actually see a full neutralization of the myotoxic effects. And this we were super happy about and super excited about. And then you're all thinking, yes, this is a pre-incubation assay. Can you make it work in a rescue? And we were quite confident that we could do that, but the experiment disagreed. So here we see, I'll quickly go through the method. We injected whole venom into, when I say we, I actually mean Bruno and Julian. I'll just want to clarify that. Intramuscular injection of whole venom. Then this was allowed to act for 3 minutes. Then we had an IV injection of either antibody or full antivenom. And then 3 hours later, we measured the CK levels. And in this study, because this was the initial study, we used a quite high 1-to-6 toxin to IgG ratio, because we wanted to see if we had an effect before we found out how good our effect was. But that's not considerations we have right now. Now we need to figure something else out. Because we have the same thing here. Negative control, we want to be here. We don't want to be here. We especially don't want to be here. Because here we have added the venom. Then after the venom, we added the our antibody. And then we actually saw a potentiating effect of the venom. So it wasn't just no effect. It was actually potentiating the venom now, which is a bit of a problem when you want to neutralize it. And we saw the same thing happen when we had the current antivenom that neutralized the B asper venom as it should. Should do it a bit better, but in this case, it did it to this level. And when we added our own in, we again saw an increase in toxicity. And we also tested if we had the antibody by itself, and that didn't harm the animal at all. So it's only after the venom has been added and allowed to act for 3 minutes in this case, then when we add our antibody, it somehow becomes more toxic. And with this, I would like to thank everyone involved in this project and my PhD in general and all the founding bodies. And then I would like to open it up for a brainstorming session in a second.
Fantastic. Does anyone want to offer their brain?
Well, the comparison between the antivenom that was acting and the monoclonal is not so comparable, because you are working with a solution that contains perhaps 10% of the anti-myotoxin versus a pure monoclonal that is 100% homogeneous against the myotoxin. So there could be problems in the combination of those. But imagine that have you done competitive assays of the purified both antitoxins from the antivenom and the monoclonal to see if they are competing for the same epitope or for different epitopes? Because it could just happen that one monoclonal maintains or release the myotoxin from its site and maintains it in solution in a complex that is not being neutralized and is still active in the body. So there are many possibilities, but we need to have structural ground to rationalize their competitive or anti-competitive activities.
Yes, I agree. We also we kept in mind that there's probably not the same amount of neutralizing material against myotoxin 2 in them. and that we overshot quite a bit with the antivenom, so we got more in there. But there seemed to be, from older papers, there seemed to be this threshold that it can only neutralize about 70% of the myotoxic assays. I think it was Bruno that published it many years ago. Regarding the competitive assay, I do agree it would be informative to see if they target the same epitope. But I mean, we can see that we target, at least it seems that we target a neutralizing epitope, because we've seen neutralization with SCVs in vitro. I didn't show data on that. We've seen it with IgGs. So we can see that we neutralize, just not when we're doing it in the rescue assay.
Christopher.
Yeah, maybe they are targeting different points. Yes.
First of all, congratulations. I think it's a really nice piece of work. Can you just back up a bit, probably the slide beforehand? I'm just trying to understand where you show the CK levels. So when the venom by itself is added with nothing else, what's your baseline CK? Around about 10,000.
Yes.
And then you're still seeing that with the addition of the various antibodies. The problem probably is that even with that 3 minutes of exposure, there's enough damage done that the cells will keep releasing CK for a period of time, regardless of whether you've neutralized the myotoxin or not. You may actually need a different measurement of the effectiveness of the antibody than just the CK rise, because we see it in snakebite patients, for example. They come in envenomed, we give them antivenom, and their CK level on day one may be 6,000. The next day, even though they've had full resolution of clinical symptoms, their CK is 35 or 40,000, because it takes a while for the CK to eliminate, and then over subsequent days, it gets out of the system. So it may be that you just actually need a different measurement of the neutralization effectiveness.
Yeah, it could definitely be useful with a different measurement. But I think what's important to notice here is that we increase the CK level. So these are done at simultaneously. So we have.
It could also just be the vagaries of the physiology of the individual test animals.
Yeah, we've seen this, like these are done with 5 animals, and we've seen that with 5 more animals. And we also see the same thing with the antivenom over here.
Yeah.
It could be an experiment's artifact, but I would be surprised with the results we've seen, unfortunately. Although I would like to contribute to that.
I mean, even an immunoassay to measure the circulating myotoxin to see whether or not it's actually bound and eliminated might be useful.
Yeah. On the plasma of the mouse, I assume. Yeah.
One in the corner before you, and then you will be. Oh, that you could go first.
Okay, thank you. I just wondered if the myotoxin causes systemic myotoxicity, or if it's just causing local myotoxicity, which would be quite different. And it may be, if it's systemic that you're interested in, then maybe injecting the venom not into the muscle might allow you to see more of an effect.
I can't remember how much of a systemic effect. I think it's mainly, as with most tissue damage, is mainly locally. It could also be interesting to inject it IV. I think the IM injection is a bit more like an actual bite. Subcutaneous, yeah. Yeah, that could. Yeah. Yeah, I'll take note of that. Thank you.
Hi, what you've described I've seen before, but
That
I'm
sounds
struggling
wonderful.
to remember where. But certainly you should look at the dengue literature.
I should look at,
Because-
sorry, what?
Dengue,
Dengue literature.
Yeah,
Okay.
because there's the 4 serotypes. And if you get infected with one, if you get sick with a heterotype, you actually get an enhanced antibody binding response. That's why you get much more severe disease. That's the clinical important bit. But there is the background lab work behind that, largely from Gavin Screeton's group and Nicholas Ray in Paris. And I think that's the literature that might help you. My suspicion is, following on from David's thoughts, is binding assays. Go back to your antibody library and find things which are partial competitor binders in a lysolite type binding assay. And cocktails may get you through this issue.
Okay. Thank you. And if you have any ideas or comments that you come up with afterwards, please shoot them to my email. I would like to hear the crazy ideas and the mundane ideas, just all of the ideas.
Thank you.
And I can quickly tell you, if you look at current approaches here, you can see what we've decided to do. We've decided to say it's could have something to do with either the bivalency of an IgG, so we are testing Fab fragments, or also some of the mutations we've set on the IgG scaffold, or something with the FC effector functions. That's what we are hoping right now. Thanks for all the feedback.
Thank you so much. Yeah, and for